Let's take a look at our rules for divisibility. Now we can really look at our rules for divisibility in three parts. So the first part is our 2, our 5, and our 10. Now this one I call our last digit rule. And I'll show you why. So if we were to take a look at 2, for example, let's count by 2s. 2, 4, 6, 8, 10. Or if I jump up, let's say 32, 34, 36, 38, 40. And let me do that one more time. 82, 84, 86, 88, 90, and so on. What do we notice happens every time? Oh, it always ends in 2, 4, 6, 8, or 0. 2, 4, 6, 8, or 0. 2, 4, 6, 8, or 0. In other words, we now know these are all even numbers. Okay, so that's our rule for 2. Just look at that last digit as long as it's even. Now let's take a look at our 5s. 5, 10, 15, 20, 25, 30, and so on. What do we notice here? 5, 0, 5, 0, 5, 0, and so on. So if it ends in a 5 or a 0, it's divisible by 5. And then finally, our 10s. 10, 20, 30, 40, and so on. They always end in that 0. So our 10s are that. So really all we need to worry about is that last digit. So what we do is we check the last digit. For 2, if it is even, which means that it ends with 2, 4, 6, 8, or 0, it is divisible by 2. For 5, if it ends in 0 or 5, it is divisible by 5. And for 10, if it ends in 0, it is divisible by 10. So we just saw those a second ago, and that all makes sense to us now. Okay, so that's our divisibility for our last digit ones. That's our 2, 5, and 10. So let's check those off. We've now figured those out. Okay. Now let's take a look at our 3 and our 9. I'm going to jump and I'm going to look at 3 and 9. Now this one's not the last digit rule. This one we call the sum of the digits rule. And let me explain how this one works. So we said this is our sum of the digits rule. So let's take a look at some multiples of 3. And if I take a look at 30, 33, 36, 39, 90, 93, these are just some samples. If I do 3 plus 0, I get 3. 3 plus 3, I get 6. 3 plus 6, I'm going to get 9. 3 plus 9 is 12. Now for 90, 9 plus 0 is 9, and 9 plus 3 is 12. Notice all of these are multiples of 3. So if the sum of the digits is a multiple of 3, then we now know that these are also divisible by 3. And if we take a look at our 9s, 2 plus 7 is 9, 3 plus 6 is 9, 9 plus 9 is 18, 1 plus 0 plus 8 equals 9, 1 plus 1 plus 7 equals 9, and 9 plus 9 plus 9 is 27. We'll check it out. These are all multiples of 9. So they are also telling us that these numbers are divisible by 9. So the sum of the digits rule, what it tells us is to add the digits if it is a multiple of 3, the sum will be a multiple of 3. If it is a multiple of 9, the sum of the digits will be a multiple of 9. Let me just make that a little easier for you to see. Okay, so there you are. That's showing us how to do that part of the divisibility. All right, one last set of divisibility is our number 6. Now, number 6 to me is the easiest. You've already done all the work because 6 means, or 6 is, if 2 and 3 are divisible, then 6 will be also divisible. So this is the 2 and 3 rule. And that is our last one, the 2 and 3 rule. So the last one is that 2 and 3 rule, and that is if a number is divisible by 2 and by 3, it is also divisible by 6. So just to remind you, the 2 and 3, if a number is divisible by 2 and by 3, it is also divisible by 6. So as a reminder, if we take a look at our rules, 2, 5, and 10 are our last digit rule. So that is for 2, 5, and 10. The sum of the digits rule, that's for your 3 and your 9. And then finally, the 2 and 3 rule, that's for the 6.